Okay, let's take a look at this example right now. We have a crate or a box here that is initially at rest. Okay. What are the forces if we take the crate to be our system? What do you think? What are the forces acting on the system? If it's resting on a surface, okay. What do you think? What are the forces that are acting on the system? So if the box is resting on the wood, this is a wood, okay. The forces that are acting on this crate or box are the normal force, okay. And let me represent them. Okay, I will. Mm, okay, these are the forces that are acting on the crate. So Fn, which is the normal force. Actually, normal forces are exerted by a surface on the objects that are placed on it. So this wood, okay, this surface exerts an upward normal force to hold this crate. Okay, so it's like holding the crate. So its force will be Fn directed upwards. G, it's the gravitational force or the weight of the object that is pulling it downward. Okay, so the weight is always directed vertically downward. Okay, these are the forces that are acting on the crate. What do you think? This box here, this crate, is at rest. It's not accelerating upward or it's accelerating downward. So what do you think? What is the net force or the sum of the forces that are if Fn and Fg are the only forces acting on the crate, what is the sum of these forces? The sum of the forces is equal to 0 actually. Okay, why? Because it's not accelerating in upward or downward. Box is not going in this direction and not moving at all. So Fn plus Fg is equal to 0 because the box is at rest. Okay. Now let's apply a force to this box. Okay, this force, and we chose wood. So wood, the surface wood, this surface will be exerting a friction force. A friction force is a force that opposes the direction of motion. Okay, it is the force that opposes the direction of motion, and it is exerted by rough surfaces on the object. So in this example, we have a rough surface, which is the wood. It will be exerting um, um, a force. Let's see how it will be exerted. Look, Fa is F of the person, F applied, okay, the applied force. So now when we increase uh, actually the force applied, okay, the crate started moving, okay. After that, it wasn't moving. And so F applied is represented by Fa. It was directed to the right. F small f, look, small f, can you see it? Which is this one. This is the force of friction, which is opposite to the direction of motion. Okay. I hope this video was helpful.